Right now, orbiting between 210 and 280 miles above the Earth's surface is a permanently crewed 12,000 cubic foot modular outpost called the Tiangong Space Station. Tiangong, which translates to Heavenly Palace, is China's first long-term orbital habitat. This image shows the Long March 5B rocket sitting on a massive mobile launch platform at the Wenchang spaceport. Getting a weightless station into orbit requires an unimaginably heavy terrestrial supply chain down here on Earth, complete with coastal launch pads and heavy-lift vehicles. Putting pieces of metal into the vacuum of space requires intense engineering. It requires a highly orchestrated, state-led industrial ecosystem capable of coordinating hundreds of thousands of people over decades. To see how China plans to build out the future of deep space exploration, we have to look back at the Cold War survival tactics that forced this program into existence. The Chinese space industry formally began in October 1956. The catalyst was the return of Qian Shusen, a world-class rocketry expert who had co-founded the Jet Propulsion Laboratory in the United States before returning to China. Under his guidance, the state initiated a project known as 2 Bombs, 1 Satellite. The goal was to master 3 highly specific technologies: nuclear weapons, the ballistic missiles to deliver them, and artificial satellites to prove orbital capability. The motivation was entirely military. Facing pressure from both the United States and the Soviet Union in the mid-1950s, the Chinese leadership needed to establish nuclear and ballistic missile dominance to guarantee their own strategic independence. The state poured resources into the mandate, and it worked rapidly. By 1967, China had successfully tested both atomic and hydrogen bombs, and in 1970, they launched their first artificial satellite into orbit. For its first 5 decades, this program operated as a massive defense initiative. As China's economy boomed into the 21st century, the state took that mature, military-grade missile infrastructure and pointed it toward a new goal: space colonization. This diagram illustrates how the Chinese space program is organized today. Unlike the United States, which centralizes its civil space exploration under NASA, China divides its administrative command into a trilateral structure with 3 distinct pillars. The first pillar is the CNSA, or the China National Space Administration. This is the civilian face of the program, a government bureau that handles international treaties, public diplomacy, and the management of robotic lunar and planetary probes. The second pillar is the CMSA, the China Manned Space Agency. They operate the Shenzhou crew transports and the Tiangong Space Station. Crucially, the CMSA is part of the Equipment Development Department of the Central Military Commission, meaning human spaceflight reports directly to the military. The third pillar is the CAS, the Chinese Academy of Sciences. They act as an independent, research-driven body that designs specialized scientific payloads, like space telescopes and gravitational wave detectors. This blended structure often draws international criticism for blurring the lines between civil and military operations. However, it creates a highly streamlined, deeply funded pipeline that can execute complex, multi-decade missions without having to constantly lobby for budget approvals. Those 3 agencies manage the policy and design, but the actual construction falls to massive state-owned enterprises, primarily CASC and CASIC. CASC, the China Aerospace Science and Technology Corporation, is the dominant industrial contractor. They physically build the Tiangong space station modules, the robotic lunar probes, and the workhorse Long March rocket family. Look at this image of workers surrounding a Shenzhou re-entry capsule on the manufacturing floor. These state-owned conglomerates employ hundreds of thousands of people, creating an industrial base capable of mass-producing spacecraft components. The agencies provide the blueprint, but this vast network of state enterprises actually bends the metal, fuels the rockets, and puts the hardware on the launch pad. For decades, China launched its rockets from sparsely populated inland sites like Jiuquan and Xishang. This created a strict physical bottleneck. Rocket components had to be transported by rail, meaning they could never be wider than a standard train tunnel. To build a modern space station, they needed bigger rockets. They built the Wenchang Satellite Launch Center on the island province of Hainan. Sitting directly on the coast, massive 5-meter rocket stages can be delivered entirely by sea. This globe visualizes another major advantage. Wenchang sits just 19 degrees north of the equator. The Earth's centrifugal force from rotation is strongest at the equator, essentially giving departing rockets a free boost. Launching from this latitude naturally increases a rocket's payload capacity by over 7% compared to the inland sites. Solving that heavy lift logistical bottleneck was the absolute prerequisite for putting massive pieces of infrastructure into orbit. The immediate result of this expanded launch capacity is the Beidou navigation satellite system. Completed in 2020, Beidou is a network of 30 satellites providing precise positioning, timing, and communication services across the globe. Before Beidou, Chinese maritime, agricultural, and military logistics relied on the American-owned Global Positioning System. Now they have an entirely sovereign orbital network that operates independently of foreign telecommunications or internet reception. By saturating low Earth orbit with their own secure infrastructure, China established a reliable, self-sufficient foundation. They are using that foundation to push further outward. This photo shows the physical tracks left by a Chinese rover on the lunar surface. Recently, China's robotic Chang'e missions returned samples from the moon's polar regions and achieved the first-ever soft landing on the lunar far side. Those robotic probes are surveying the terrain for the next major phase of the program, the International Lunar Research Station, or ILRS. This schematic reveals the planned layout for the ILRS. Targeted for basic operation by 2035 at the lunar South Pole, it's a scalable facility featuring nuclear power arrays, autonomous rovers, and communication relays to support long-term research and resource extraction. The ILRS is also a geopolitical project. China has formally partnered with Russia and extended invitations to other nations to co-build the station, creating a parallel international coalition distinct from Western-led lunar efforts. In less than 70 years, the Chinese space program evolved from a desperate measure for nuclear survival into a self-reliant, fully integrated industrial machine. Today, that machine is actively laying the groundwork to become a primary architect of humanity's expansion into the solar system.